Hello, welcome to StreamAnalytix. In order to build a data pipeline, data sources are recognized as channels. In this demo, I will show you the data source operators that are available in StreamAnalytix and how do we use them in our applications. You can build your data pipeline on our visual drag and drop interface. We call it the pipeline canvas or designer. Channels are the built-in drag and drop operators to consume data from various data sources such as message queues, log files, transactional databases, etc. And once the data is received, you can further process it by applying various transformations or business logic on it using a wide range of processors and emitters. Based on your use case, choose the type of pipeline from streaming or batch. We bring you several channels where you can read the data. For instance, TweetStream, ClickStream, AWS IoT. Several advanced data sources are also available such as Kafka, JDBC, DFS, S3, etc. Also, if you require a data source which is not available, then you can always create a custom channel. And as you can see, that some of the channels are grayed out on the screen. That is because they are not available for streaming pipeline. Our use case for today is air pollution analysis. And here we'll be reading air pollution statistics using Kafka channel. At first, we start by creating a message. A message in StreamAnalytix represents the schema of data, which will flow through the pipeline, and in order to configure your schema, go to the message configuration and click on this plus icon. For this demo today, I've created a message for pollution statistics schema. Let us look at it. Provide a relevant name to your message. Assign it to a group and choose the parser type. Parser type could be JSON, Avro, delimited, etc. Then add fields to your message from the Fields Configuration tab. We have configured the fields in our message to represent air pollution statistics schema. Some of our fields are carbon monoxide, particulate matter, wind speed, ultraviolet index. Based on the data in the fields, provide the data type for the fields. For instance, wind speed can be 26.8 mph, so we are keeping it as decimal. Our message schema is ready to be ingested. Now we will fit in this message in our data pipeline. I have created this air pollution use case pipeline. You can edit the pipeline to view its configuration. This is our pipeline. We're reading data from Kafka. It gets filtered based on particulate matter and carbon monoxide levels. Then filtered stream gets published on RabbitMQ. Let's see how Kafka is configured to read the data. This is Kafka's configuration tab. Select message lets you choose one or multiple schema for the pipeline. If a single data source contains data in multiple schemas, we can choose multiple here. For this use case, Kafka channel has data pertaining to single schema. Let us see the configuration tab. Kafka is a publish-subscribe messaging system, therefore it needs topics to read and write data. Now, let's configure Kafka. First, we need to select which Kafka cluster are we reading the data from. You can choose from the pre-populated list of Kafka connections. Then, we need to provide a topic name in Kafka. It is from where the messages will be read. Then we enter an ID for Zookeeper to track messages. To keep it simple, it can be same as topic name. Provide the number of topic partitions. Replication provides stronger durability and higher availability. Now, if force from start is set to true, every time you run a pipeline, it will pull data from start of the topic. Following properties help you to deal with connection failure between Spark executors and Kafka. So in number of connection retries, you can specify how many times this pipeline will retry in case of a connection failure, and delay between connection retries can be configured in milliseconds. Let me also show you how I have configured the filters. We have applied a filter rule that will only emit data when value of both particulate matter is greater than 10 and 251. Similarly, we can view the configuration of carbon monoxide filter, which will only emit result for carbon monoxide levels above 0.4. This is the configuration of RabbitMQ, where we will observe the carbon monoxide level filtered stream. You can configure the topic, exchange name, and routing keys for the same. And similarly, we have also configured RabbitMQ for PM levels filtered stream. We'll now save and start the pipeline. Since the pipeline is in active mode, you can observe the data on RabbitMQ. The topics that we configured in our pipeline are reflected here. You can observe the messages. They are filtered as per our requirements. The carbon monoxide level is above 0.4 and the particulate matter level is 840. Our pipeline is running successfully. Our ingenious channel Kafka and other operators allowed us to view the anticipated results. You can learn more about our built-in operators on our YouTube channel and our documentation page. Thank you for watching this video. For more information on StreamAnalytix, you can visit StreamAnalytix.com or drop us an email at info@streamanalytix.com. Bye.